Polymorphic consensus blockchains are blockchains able to switch their type of consensus while running. And I demonstrated an implementation of this concept in previous videos with Raft, Tendermint, and Avalanche consensus protocols. This is done on a blockchain where each consensus protocol is a smart contract. We also talked about imperative and recursive revertible consensus as a meta-consensus protocol, but you can take it one step further. You can have a meta-consensus protocol that switches between types of consensus based on observables. If we think of it in terms of public blockchains, the observables are number of available validators, network bandwidth or congestion based on the amount of pending transactions, quality of time sync, which is how validators maintain a measure of time consistent with each other, and specific observables for the type of consensus. For example, proof of stake consensus requires a fair balance of stakeholder assets. If a chain reaches a great imbalance of assets, but you want to maintain decentralization, you may want to change the protocol. Geo-clustering is also a factor. You may want to balance validators based on geo-clustering to ensure that the chain survives if one of these clusters goes down at the same time. Client software clustering. Blockchains like Ethereum have invested a lot of resources in creating different clients to avoid centralization on a team of people and to counter implementation bugs. Based on these observables, a chain may choose to change its consensus parameters or the consensus protocol altogether. And all of this is done automatically by meta-consensus protocols accepted and improved by governance. You can even have your node automatically download another type of client by this meta-consensus protocol. A minor consensus switch is a parameter change or improvement based on observables. A major consensus switch means a change in the type of consensus, and this is a matter of changing the consensus smart contract. It can be by revert or by consensus composability. So you can switch to any of the consensus protocols available on that chain at that moment in time, and you can add more protocols anytime. Consensus composability is as wide as the composability of smart contracts because protocols are smart contracts. And consensus protocols for machines are tightly linked to consensus protocols for humans. An explosion of use cases in one will create the necessary conditions for an explosion of use cases in the other. Each human is tightly linked to one or more machines that need to be in consensus with the other humans and machines. So consensus composability will extend to human consensus and the landscape of human relations and how we reach consensus from small local groups to nations and beyond. Complex machine consensus is a requirement to expand the landscape of human consensus.